falling object. In this experiment, I analyzed the motion of an object, a face mask, falling from rest and attempted to model its position over time using the effect of gravity with and without drag in order to determine which could best model the object's motion and which best predicts terminal velocity. So this is how I initialized my conditions for my first computational model. I start off by using the vector position from tracker, and I added in the gravitational constant, which is 9.8. I set b equal to 0 because we're only focusing on gravity in this first model, and we're not looking at air resistance. I put in the final time in the while loop, and for calculating the net force, I used the vector which has gravity in the negative y direction. For computational model B, it's around the same thing, except that I had to change my B value to be non-zero. So it was a lot of trial and error to figure out which one best modeled the object's position, motion. 8.85 was the best value I got. And then for calculating the net force, it was this vector plus that vector, which is the formula for the drag force. Over here is the position update and the velocity update formulas. So the comparison between my model and my experiment. As shown in the graph, my second computational model turned out to be the more accurate representation of the object's motion with a nearly identical slope as that of my experience. It diverges a bit early on, but it better matches it way better than my first model, which is only looking at gravity. So looking at velocity versus time, if you're comparing the first model, which is the one on the left, versus the second model, which is the one on the right, the second model better predicts terminal velocity. Terminal velocity happens when drag force pointing up has exactly balanced force of gravity going down. So this means that the net force is 0. What if? So if an object was thrown downward, and we're comparing the terminal velocity from between that and in which an object is dropped from rest, it will reach a terminal velocity faster than that of an object dropped from rest. And that's because, well, in the model, you have to make the initial velocity non-zero. I'm sorry, that was terrible. That's all.